Alright, so let's talk about the reaction of diols in order to form epoxides. Now, epoxides are probably most easily formed by the use of a peroxy acid. But in this case, we're going to look at it in terms of our diols. Now, diols can easily be made by doing something like potassium permanganate added to something like an alkene. So how do we convert our diol subsequently into an epoxide? Well, the trick here is that we're going to use sodium hydroxide, or a strong base. Now, our strong base here is going to abstract a hydrogen from one of the oxygens in the mechanism and generate the alkoxide. For this reaction to occur, these actually had to be on opposite sides. They had to be anti to one another. So, even though I've drawn these two diols here on the same side, being in the eclipse conformation, ultimately what has to be able to happen is that this group is going to need to rotate so that this oxygen here and this oxygen here are eclipsed. What subsequently follows is nucleophilic attack of the alkoxide to the alcohol position. So our lone pair here will attack this carbon, displace this oxygen, and give us the recovered hydroxide. So, a few comments on this type of reaction. First of all, if we cannot get the alcohol functional groups to be opposite one another. So something like this would be if we had something like cyclohexadiol. Cyclohexadiol here is only going to will only be able to form an epoxide if and only if these oxygens are on opposite sides or opposite faces of the ring. If these end up being cis to one another, this reaction would not occur because they're not in a position to undergo the attack. The other is that we don't really have a preference for which oxygen we work with. So it doesn't matter which oxygen we work with, one of them is going to get eliminated. Now, a thing to kind of keep in mind when you do this reaction, as I drew this, I drew these two being eclipsed. If this is R1, R2, R3, R4, and you do this condensation, this does not end up being R1, R2, R3, R4. They end up rotating. And they end up rotating because we had to rotate along this single bond in order to get these alcohols anti to one another. So when you do these reactions, my recommendation to you, build the model and then rotate it into the anti-conformation to make sure that you're keeping the R groups in the appropriate place. This is how it's actually attacking. So when we do this rotation, this ends up being R3, R3, R4. When we finish, it's going to show you much more clearly where those functional groups ended up when you're done.